Hello guys, my name is Abdurrahman Gilal, and in this video I'll be explaining you array list versus linked list. What I mean is that both of them are data structures. So first of all, what is data structure? Data structure is basically a way by which we organize a huge amount of data in an effective way that if we wanted to manage or if we wanted to access or if we wanted to, do manipulation, anything to the data in an effective way. So we have already discussed what is array list, and in that video I explained you that how arrays are different with array list. So I told you an example that array list is basically implementing the list interface. So in this video my focus is to propose you another available interface implementation or list implementation that is called linked list. So both of them are basically doing almost the same thing because both of them are implemented over the list interface, and both of them show us the output exactly in the same way. So they have a similar method, they have a similar fields, but the way they work behind the scene is different. So in this video, I'll be explaining you how both of them are working behind the scene. So let's say, first of all, let's quickly create an array list. So how do we create array list? So first thing is that we have to write array list. So if you are using an effective compiler, so you will automatically bring out this library that is array list. But if you don't, so you should be importing a java util.array list. And here you pass the wrapper class. So I'm gonna say like this time I'm using this string, and I'm gonna say like this is my array list. So you can put any names into it. So I'm gonna just simply say, so here you're gonna put like array list, similar things, and then if you wanted to add some elements or something, so I'm just gonna make it straight away for that. So this is my declaration for array. And then how about linked list? So I have to use the same thing, linked list. So you see array list and this is linked list. As soon as you write, this comes up there. So basically, if it doesn't come up there, you have to import this library. So now you have to call the same thing. So similar way, sorry about that. So here you say linked list. This is what you bring, right? So same thing. There you go. So both of them, you're gonna see like no difference at all. Both of them are using the same way, but here we use array list, here we use linked list. So that's one of the things. So now you wanted to add elements. So how you add elements? So you simply write add and then you put here any value. For example, you wanted to say apple and you wanted to say like, let's say orange, and then you're gonna say banana. So anything that's there, now it will be stir. If you wanted to print out, so you're gonna simply say add a list and you will be getting them printed. But let's say if you wanted to use the same thing in the linked list, only a thing that you have to use here is to just change this part and sort of that, yeah. And here, same thing. Yep. So let's run it and see like if it works fine. You see, we do not see any difference. So this is how I'm gonna say arrow list, and this is gonna say linked list. So if you are working on array list based on output, can you differentiate between both of them? No, not at all. So how does it really work behind the scene? Let me sketch a diagram for you. So this is going to help us to understand in a better way that if now we understand. Let me start up the annotation. Yeah. So the first important thing, as soon as we declare the array list, so what happens? We get a space in the memory. Let's say this was the name of the variable, so A was smaller, and then we get this space in the memory all connected, right? So let's say here we have, let's say apple, and then we had orange, and then we had banana. And then all the elements are now accessed through 0, 1, and 2. But that looks pretty straightforward in array list. But how about linked list? Linked list does not basically work that way. Linked list, because this one gives us the space in the memory all together. That's one of the things. So let's say if you wanted to, how to say, add another element. So if the space is available here, it's gonna give you the space here, right, straight here. But if it's not, what it's gonna do behind the scene without we know anything about that, it will create how to say a space, and it will add an element and then duplicate all the values here and eliminate this developed array, and then will start pointing out here. That's something like it's gonna expensive, very expensive behind the scene. But here in linked list, they work based on certain things. For example, give me a second, sorry about that. I'm gonna say now it's a linked list. So this is our node. In the node, we have this part is a data part, and this part is the next pointer, and this called previous pointer. So it will bring us the backward and it will bring us the forward. So it doesn't depend like where exactly are we going to store the thing. For example, here I said I had to store Apple. So Apple was stored here. Now if I wanted to go to the another side of the memory, so it will basically help me to link here, and then this is going to be the, let's say, orange, and this is going to be for time being nothing, null date, because it's nothing. So here this is going to be the data for that, and this is the previous address, and this is the next address. So basically every node, this is called a node, will have data previous and the next addresses, so or pointers. So let's say if you have this pointer to here, so basically the next pointer of this data, so this node is this one, but the previous pointer is this one. So it looks like very similar. Like let's say if you wanted to access the banana in the array list, so how we access is very pretty straightforward. We call a get method and we jump on the index number 2. But here, if you wanted to access to the banana, it does not give you like that straightforward. It has to go through here because this apple has the address for orange only, and then orange has the address of the banana. So this is why you have to traverse almost so many elements in order to reach to the place that you wanted to reach. And that's not it yet. What if you wanted to add an element? That's pretty straightforward, that you came and you add this element. So this is your new element, that was banana, for example, and this is here you reached and you don't have anything here. But what if you wanted to delete this element? So what you have to do is to just change the address of this one right here. So now this connection will automatically eliminate this orange. But behind the scene, if you're working with array list, it's not going to happen like that way. It's going to delete the element by creating another array list. So this is why sometimes deleting and adding element in a linked list is faster than array list. But in order to access the element, it's faster with list. So accessing the elements, it's array list is better. Deleting or let's say or adding, better effective in linked list. So now let's say let's run it and see like how it appears then when we try to work. Do we have any physical difference that if you wanted to remove an element from here? So let's say I'm gonna say linked list dot remove. So there you go. And here you can pass directly, you wanted to say apple, you wanted to delete, or orange, you wanted to delete. So you can simply call orange, and this is going to basically delete that one. And when we print it out, so we don't have apple orange here. So what happened behind the scene is they just delink the next address. So it's automatically deleted. But here you wanted to delete the same thing, that array list dot remove, and then you wanted to remove the orange here. It has not happened that pretty straightforward way. So what has happened behind the scene for sure that okay, is there anything wrong? Okay, so okay, I think pretty straightforward. Like let's say I'm gonna say like my spell was wrong. Yeah. Excuse me. Yep. So now I'm gonna see like if my element, yep, it's pretty straightforward, it's deleted. So I can also delete with the index, which is let's say 2 or 1, whatever. So I'm gonna say like let delete it with 1. So this is 0, this is 1, so it's automatically deleted. So it's still gonna be the same, right? So once again, I must tell you that both of them, if you wanted to see like in terms of behavior, they show us the same behavior. but in terms of having access to in memory or elements, in terms of adding and deleting, definitely both of them are working differently. So in array list, we have everything homogeneously at one time available. If you wanted to add or remove, what we do is that the behind the scene, the array list is creating another list and duplicating all the values. And then, for instance, I just explained you, okay, here this is gonna be like we are adding an element. So if we already have three elements here, 1, 2, and 3, and then we are adding another element between here. So what happens at 1 and 2 is pushed back here, and 3 is here, and then whatever element, like I put 6 here, so 6 comes here. So then this list is removed. But in linked list, because we are dealing every element independently, so only a thing, for example, we have to change the addresses this way, let's say. So 3. So previously it was linked with this one. Now we just simply link this one in here, and then this one with here, and this was already connected with this one, and this has nothing, no address, because the first element will have not the previous index, and the last element will not have the next index. So this is quicker. Like if you have any element, like any element to delete or add, I think linked list is the best option. I hope it makes some sense. If you have got any question, please do not hesitate to drop me in the comments.